Detecting and enhancing loop level parallelism. Loop level parallelism is normally analyzed at the source level. Okay, instruction level parallelism is done once instructions have been generated by the compiler. Source representation. This is an example where this is one instruction given. Xi is again in the RHS, it is given as again as Xi. There is a dependence between the two uses. The first use is this and the second use is this. But the dependence is within the single iteration. Hence, it is not a loop carried. What is a loop carried dependence? If a data accessed in later iterations are dependent on the data values produced in earlier iterations, then it's a loop carried dependence. This is a second example where ai plus 1 is this and bi plus 1 is this. There are three dependencies you can find. One is this and this, second is this and this, third is this and this. The first one, this and this, is a loop dependence because there are two different iterations, I and I plus 1. Even the second one is a loop dependence because it is I and I plus 1. But the third one is not a loop dependence because it has the same iterations. I plus 1 is here and I plus 1 is here. Okay, finding dependencies. It is important for good scheduling of code, determining which loops might contain parallelism, eliminating name dependencies. A dependence exists if two conditions are held. If two conditions hold, there are two iteration indices j and k, both within limits of the loop, of the for loop. M is less than equal to j is less than equal to n. M is less than equal to k is less than equal to n. The loop stores into an array element indexed by a into j plus b and later fetches from that same array element when it is indexed by c into k plus d. That is, a into j plus b is equal to c into k plus d. We cannot determine whether a dependence exists at compile time in general. A simple test for the absence of a dependence is Great Common Divisor test, GCD test. It states if a loop carried dependence exists, then GCD C, A must divide D minus B. We'll take an example for this. Use the GCD test to determine whether dependencies exist in the following loop. This is a loop given. This is the iteration. Now, when you compare this with this formula, we'll get the values of a is equal to 2, b is equal to 3, c is equal to 2, and d is 0 here. Hence, GCD of a and c, which is 2 and 2, is 2 only, and d minus b, which is 0 minus 3, will give you minus 3. 2 does not divide minus 3, hence no dependence is possible. Thank you.